Hello, everyone. Welcome to today's session. My name is Sulaiman Adejumo, and today we'll be talking about practical API design and integration. So in this session, we are going to focus on clarity, consistency, and how to avoid the common mistakes that developers often make when working with APIs. So whether you're building an API or you're consuming one, the main goal is the same, to basically create systems that can talk to each other in a reliable and predictable way, right? So let's begin. So in this slide, we're showing the roadmap for today's session, and we'll start by looking at what an API actually is. So not a long definition, but the most important idea, of course, that an API is a contract between systems, just that. And after that, we'll move into the practical of how to parts basically, and that includes how to name your endpoints properly, how to choose the right HTTP methods, how to structure your JSON responses so that they are predictable and easy to work with. We'll then talk about how to communicate failures clearly, because obviously error handling is a big part of the real world API work. From there, we'll look at how APIs scale using pagination, filtering, and versioning. Finally, we'll then touch on the other side of the equation, not just the designing of the APIs, but integrating and consuming them safely and correctly. And by the end, you should have a clear mental model of API rules, set of practical rules that you can apply immediately. Right. So let's start with the first point, what an API really is. We need to stop thinking of APIs as just code and start thinking of them as a contract, as mentioned before. So when a front end or mobile developer connects to your back end, they are effectively signing an agreement, and that brings us to the promise. So your API promises that if an app makes and asks for user data in a specific way, you will return it in a specific format every single time. So now, why does that matter? This is where the risk comes in. Yeah. If you silently change the format, for example, you rename a field, or by removing one, you're just now updated the code. That means you have broken the contract. So you just rename a field, you've broken the contract. The app will crash. The user blames the app and not the API. So that is why the goal of API design is not just to do things how you like. It's not to be complex or just to be clever. The goal is to be predictable. So basically, a boring API is usually a very good API, right? So how do we name these contracts? The rule is very simple. We just use nouns, not verbs. Your URL should describe the thing, the resource, and not the action you are performing on it. And if you look at the bad example on the screen, the get users, it is redundant. Why? If you ask, because the HTTP request itself is already a get, and you are already saying you are just basically saying the same thing twice. So instead, follow the good example, just use /users. Right? So the action is already expressed by the HTTP method, which keeps your URLs clean and easy to understand. And finally, consistency matters a lot. So pick a lane and stay in it. So I would strongly recommend always using plurals. Even if you are fetching a single product, use something like /product/ID, finish. So this saves the front-end developer from guessing, is it a product or products this time? So something like that. And moving on, we communicate intent in an API through verbs. So if you are only reading data, use get. Get should be safe, meaning it never changes anything in the database. And if you're creating something new, use post. For updates, there's an important distinction. Put replaces the entire record, the entire thing, while patch updates only specific fields. Okay. Now, how does the API respond to that request? It's through the status codes. So for green, do not use 200 OK for everything. So if a record was created successfully, return 201 created, and that tells the client, look, this worked and a new resource now exists. And if the user sends a bad or invalid data, return a 400. If something goes wrong on the server, that is a 500. And finally, please make sure to avoid the anti-pattern at the bottom of the slide, as you can see. So never send a 200 OK status with an error message in the response body. It confuses clients, libraries, breaks error handling, and it just creates a very hard to debug problems for everybody. Moving on. So predictability is king. Like I said earlier, a boring API is a very good word, especially when it comes to response data. Let's start with shape stability. So if I request a user profile today, the JSON structure should look the same tomorrow. You should not add or remove keys dynamically based on the data and just do it that way. Next, keep your responses flat. If a developer has to write something like response.data.user.profile.geo.lat just to get a number, the JSON is too deep. You can't be doing that. So flattening your data makes it easier to read, easier to debug, and easier to work with. So finally, data types matter a lot, and this is a huge source of bugs. If a value is a number, send a number, not a string. If a value is empty, send null explicitly. So do not simply omit the key because the client might assume the field does not exist, which can lead to more crashes, basically. So, so when things go wrong, the API would still need to be helpful. So this is an important concept. Error messages are actually user experience, but for the developers using your API as well, avoiding lazy error messages, returning a plain text string like invalid inputs, or not useful. So it does not tell the developer what was invalid or how to fix it. Instead, try and adopt the structured error objects, provide a code so that the client software can reliably detect the error, provide a message that can be shown to the end user as well. And most importantly, if the error is related to a form or input, return the field name. So this allows the front end user to highlight exactly which parts has caused the problem, which input has caused the problem, saving time for everyone involved. Makes life easier. Basically, as your application grows, you eventually have to deal with scale. And let's start with pagination. So never allow a client to fetch all of your data at once. If you have 10,000 users and you return them in a single response, you will just overload the server. So always set a sensible default limit. For example, 20 items per page. That's what a sensible limit would mean. It basically depends on the kind of application you're building, but try and make sure there's a sensible limit there. So next is filtering. Keep your URLs clean and predictable. Do not create endpoints like get red cars or something like that. So instead, just use query parameters such as /cars question mark color equals red, and that is basically in its own explanatory and makes life easier for everybody. So this approach would keep your API simple, flexible, and easier to extend later, right? So finally, versioning. Think of versioning as your safety net. At some point, you will need to make some breaking changes. So if you start with version 1, you can introduce version 2 later without breaking existing apps. So it basically gives you control and peace of mind as your API evolves, right? So moving on, we end with the golden rule. If your feature isn't documented, it effectively doesn't exist. So you cannot expect people to guess how your code works, but don't write manual PDFs as well. So they basically get outdated instantly. And regarding automation, use tools like Swagger or OpenAPI. They generate documentation directly from your code. And when you update the code, the docs update automatically, right? So ultimately, this is about empathy. Good documentation will show that you show care and you're the person using your work. And it also builds trust, and trust is the most valuable asset in any integration, right? So moving on. Before we wrap up, let's condense everything into a single checklist. So if you take one photo today, make it this one. Remember, your API is a contract. Keep it consistent. When naming things, use nouns, resources, not actions. Respect the HTTP protocol. Match your methods to your intent, and never lie with your status codes. Also, make sure to keep your data structure boring and predictable. Make your errors helpful, not vague. Prepare for success by pagination and versioning from day one. And finally, automate your documentation. So if you follow these rules, you aren't just writing code, you're building a product that other developers will love to use. Right. So yeah, we've covered a lot of ground in a very short time today, and I hope I've passed across majority of the points. And from naming resources to versioning and documentation. So if you only remember one thing from this talk, make it this: empathy. So when you're designing your API, you're not just writing codes for a machine, you're designing an experience for another human being, the developer, who will have to use it. So if you make their job easy with predictable consistency and well-documented code, you build trust. So, and like I said, trust is very valuable. So thanks so much for your time, and I'm happy to take any questions.